Welcome to our webinar, Preparing for IEC 62368, the replacement for IEC 60950 and IEC 60065. Thank you for joining us. This webinar is being given by MET Laboratories. MET is a leader in the testing of electrical and electronic equipment for environmental hardiness, product safety, and electromagnetic compatibility. MET operates world-class labs in Baltimore, Maryland, Santa Clara and Union City, California, Austin, Texas, and also runs operations in China, Taiwan, and Korea. This webinar will run 30 to 45 minutes with an additional 15 minutes for questions and answers. Due to the number of registrants, all attendees will have their phones muted. If you have a question, please type it in the questions area of your GoToWebinar control panel. We will attempt to answer all questions at the end. Just a quick note on other upcoming events. We are having a Global Market Access webinar on December 8th, and you can register for that on metlabs.com. Today's webinar is being presented by Mark Edge. Mark is a technical manager for MET's Electrical Product Safety Labs. At this point, I will hand over the presentation to Mark.
Hi, guys. As stated, my name is Mark Edge, and if you read the bio for the handout, you'll know that I have approximately 10 years of experience in product safety, about half of that 5 years with an independent testing laboratory, and I gained a lot of valuable experience working with numerous standards there. And now the last half of 5 years with MET Laboratories, working first as a lab manager for the Austin laboratory and now as the technical manager for the safety business line, where I've had lots of experience now working for an NCB and in RTL. What we're going to talk about today is 62368. What we'll discuss is the what, why, how, who, and when. What 62368 is and isn't. Sorry. Why it's needed, what the driving force was, why it's worth the effort, how, what are the main tenets of the hazard-based safety engineering, and what are the major differences, who, which countries or schemes are accepting 62368, and when. When will 62368 replace 60950 and or 60065? So 62368 is the safety standard for safety for audio and video equipment and information technology, communication technology equipment. It is to some extent an amalgamation of the requirements of 60065 and 6950, but not just or only an amalgamation of those standards. 62368 is based on the principles of hazard-based safety engineering, which is a different way of developing and specifying safety considerations. The implementation or application of the standard is unique and somewhat a paradigm shift in the product safety. And we'll talk about this more later, but the approach is less prescriptive and more performance-oriented, more tolerant of new and emerging innovative designs. So what is 62368, the background of it? It was developed by TC108, and while it is new to most of us, TC108's been working on this since 2002. The first edition was released in January of 2010 as an IEC standard, but was not well received. The U.S. and only 4 other countries adopted the first edition. TC108 suggested in that document that the first edition be adopted not earlier than 5 years. Coincidentally, 5 years is the length of time required or suggested before a new edition or significant modification of a standard can be released. I think it's a common opinion, and certainly mine, that in this statement, in essence, TC108 was saying, let's wait for the next edition. The second edition was published in February of 2014 and was almost immediately adopted by numerous countries. We'll go more into this later. There is no risk management inherent in 62368. However, TCA 108 utilized to some degree risk management in the determination of the levels and limits used throughout the standard. In spite of the incorporation of the 60065 and 6950 scopes, 62368 is not just or only a merging of these two standards. 62368 utilizes a combination of test methods from 60065 and 6950, but incorporates hazard-based concepts, a different way of developing and specifying safety considerations than that of 60065 or 6950. Why? 62368 was developed in an effort to simplify the problems created by the merging of technologies, information technology equipment and audio equipment, video equipment, and similar electronic devices. Really, it was an answer to this. What happens when all of this gets incorporated into we got a map for that, this. Is this a phone? Is it a computer, a music player, a projector, GPS? We all were taken somewhat by surprise, I know I was, when these technologies merged so far in advance of a classification or standard. Again, I ask you, is this a phone or a computer? We clearly needed to pass to both classify this equipment and to ensure the safety of the public and of the product. In answer to that, as we have said, 62368 applies to a wide range of products, but it also has the added benefit of better facilitating the introduction of new and innovative methods of construction and technology without first requiring amendment of the relevant standards to accommodate the new technology. Much like 6950, 62368 has an informative section, or section 0. In 62368, this section provides an introduction to the principles of safety. The objective of the introduction is to help the designers of products to understand the underlying principles of safety in order to design safe equipment. These principles are informative and not an alternative to the detailed requirements of the standard. 62368 defines 3 types of persons: ordinary, skilled, and instructed. Ordinary persons, like the users from 60065 and 6950, skilled persons from 60065 are like the service persons from 6950. These folks are expected to have training and experience in the equipment or technology, and particularly in knowing the various energies and energy magnitudes used in the equipment. Instructed persons, a term from 60065, is someone trained and or supervised by a skilled person. When I think of a skilled person, I think of a cell phone repair person who really works on the cell phones. When I think of an instructed person, I think of store clerks who change out batteries. I've struggled with an analogy here, and I have called it like a chef and a sous chef. And so it's kind of an analogy of it. A skilled person really knows the equipment. An instructed person may know how to operate it or fiddle with it, but they don't know everything about it. 62368 classifies energy sources, prescribes safety standards, or rather prescribes safeguards against those energy sources, and provides guidance on the application and requirements for those safeguards. To illustrate this, 62368 uses a 3-block model. This model represents the transfer of some energy to or from a body part. It starts with an energy source of some kind which is capable of causing pain or injury. That energy has to be transferred through some mechanism, like touching it, to a body part. There are 6 kinds of energies covered by 62368. We'll cover them here quickly. Electrical energy in Clause 5, thermal energy, like the ignition and spread of fire, Clause 6, chemical reaction, Clause 7, kinetic energy, Clause 8, thermal energy, like accessing hot parts, Clause 9, and radiation energy in Clause 10. (62368) specifies 3 classes of energy sources. These are Class 1, Class 2, and Class 3. These sources are defined by magnitudes and duration relative to either the body part or to a combustible material and its response to those energy sources. Each energy class is a function of the body part or the combustible material's susceptibility to that energy magnitude. So we'll talk about the classes here. Class 1, the effect on the body, it's not painful, but may be detectable. Class 2 is painful, but no injury is sustained. In Class 3, an injury occurs. The effects on combustible materials, Class 1, ignition is not likely. Class 2, ignition is possible but limited. In Class 3, ignition is likely. Energy thresholds are not constant. These sources are different kinds of thresholds for different types of people, even the same size and mass of people. Body variables include age, health, emotional state, and skin characteristics. For example, some energy sources, the threshold is a function of body mass. Lower the mass, the lower the threshold, and vice versa. Other body variables include age, like I said, health, state of emotions, effects of drugs, skin characteristics, and so on. Using an electrical energy source as an example, the energy limits or classifications are determined by the use of charts similar to this one. For any voltage up to the voltage limit, there is no limit for the current. Likewise, for any current up to the current limit, there is no limit for voltage. Using this chart, then an ES1 is defined as an energy source, or electrical energy source, not exceeding the ES1 limits under normal operating conditions, abnormal operating conditions, and single fault conditions of a component, device, or installation not serving as a safeguard, and not exceeding S2 limits under single fault conditions of a basic safeguard. Graphically, that looks like this. ES1 does not exceed the limits of ES1 under normal, abnormal single fault of not a safeguard conditions. If the source voltage is less than the ES1 voltage limits under normal, abnormal, or single fault conditions, the current limit is undefined. Again, for any voltage up to the limit, there is no limit for the current. Likewise, for any current, there is no limit for the voltage. So if the source voltage is less than ES1 voltage, under normal, abnormal, or single fault conditions, the current limit is undefined. And still, there's another definition for class source. The second part of that definition is that it does not exceed S2 limits under single fault conditions of a basic safeguard. So under single fault conditions of a basic safeguard, if the source voltage is less than the ES2 voltage limits, the current limit is undefined. And likewise, under single fault, the current is less than ES2 limits, the voltage limit is undefined. An ES2 energy source is defined as a class 2 electrical energy source where both the touch voltage and the touch current exceed the limits of ES1. And under abnormal, normal, and single fault conditions, either the touch voltage does not exceed the ES2 limits, as shown graphically here, or the touch current does not exceed the ES2 limits, as shown here. ES3 is defined as a class 3 electrical energy source where both the touch voltage and the touch current exceed the limits for ES2. And I say in my notes here, to infinity and beyond. Any voltage, any current, it's class 3 source above the limits of class 2. House 62368 energy limits. So the previous chart is used in conjunction with defined limits such as this table. I don't expect you to be able to read this chart, but if I look at it for you, you can see here that for voltages AC up to 1 kilohertz, 30 volts RMS or 42.4 volts peak, there's a current limit of 0.5 milliamps RMS or 0.707 milliamps peak. That's an ES1 limit. For an ES2 limit, you'll see 50 volts RMS, 70.7 volts peak, and then the current limit is 5 milliamps or 7.07 milliamps, 10 times the ES1 limit. ES3 is anything above the ES2 limits. Many products necessarily use energy capable of causing pain or injury. Just having mains connected device is one such example. Product design cannot eliminate such energy use. Consequently, such products should use a scheme that reduces the likelihood of such energy being transferred to a body part. 62368 again uses a 3-block model and introduces the safeguard as a method of reducing the likelihood of an energy transfer. A safeguard is a device, scheme, or system that is interposed between the energy source capable of causing pain or injury and a body part, and reduces the likelihood of transfer of energy capable of causing pain or injury to that body part. So we now have a source capable of causing pain or injury with a safeguard in place between the energy source and the body part. There are many kinds of safeguards. Equipment safeguards are a physical part of the equipment, like an enclosure. An installation safeguard, such as bolting a piece of equipment to the floor to prevent its tipping. Personal safeguards, and this is an odd duck in 62368. They don't actually, 62368 doesn't actually call out personal safeguards that are required, but it says that the safeguard, they don't say what safeguards are required, they say that safeguards are required though. That will be determined by the manufacturer and the agency, certifying agency. The requirements of personal safeguards are not addressed in the standard. The standard does assume that personal safeguards are or will be available for use as specified by the manufacturer. In addition, there are behavioral safeguards, ordinary instructed person safeguards, skilled person equipment safeguards. As an example, 62368 talks about electrically caused injury or pain. To have electrically caused injury or pain, you need three things: an electrical energy source capable of causing pain or injury, a transfer mechanism, two or more electrically conductive parts, another conductive part or earth, and a body. To make this more clear, we have a three-block model that we saw earlier today. In this example, the energy source is a prospective touch voltage or touch current. The transfer mechanism is two electrical contacts, and the body resistance provides the current path. Said another way, a picture is worth 1,000 words. Here again, we have the three parts: an energy source capable of causing pain or energy, transfer mechanism, a person touching part of the circuit or touching ground or touching two parts of the circuit, and then, of course, the person. Similar models can be used for all forms of energy in 62368. So bringing it all together for an ordinary person, no safeguards are required for an ordinary person for Class 1 energy sources. At least one safeguard is required between Class 2 and an ordinary person. If that safeguard is expected to be removed by an ordinary person, for instance for service, and the equipment is for use in the home, an instructional safeguard is also required. For Class 3, a basic safeguard and an equipment supplementary safeguard, together forming a double safeguard, are required, or a reinforced safeguard is required. Bringing it all together for an instructed person, no safeguards are required between a Class 1 energy source and an instructed person. For Class 2, instructed persons use precautionary safeguards. No additional safeguards are required. For Class 3, a basic safeguard and an equipment supplementary safeguard, together forming a double safeguard, are required, or a reinforced safeguard is required. Bringing it all together for a skilled person. A Class 1 energy source, there's no safeguard required between a Class 1 energy source and a skilled person. Class 2, a skilled person uses their skill safeguard. No additional safeguards are required between Class 2 energy source and a skilled person. A skill safeguard is the education, training, knowledge, and experience of a skilled person that is used to protect the skilled person against Class 2 or Class 3 energy sources. For Class 3, a skilled person uses a skill safeguard. Unless otherwise specified, no additional safeguards are required between a Class 3 energy source and a skilled person. A reactionary safeguard: if in the vicinity of a Class 3 source there exists another Class 3 source, an additional safeguard is required to reduce the likelihood of injury due to an involuntary reaction. As stated, the second edition of 62368 has been more widely accepted than the first edition. For the CV scheme, the second edition was released in February of 2014. Since then, over 19 NCBs from 14 countries have been accredited to issue and recognize CV reports and certificates. 2 NCBs are recognizing only, and 6 countries have issued national differences. The countries are Belgium, Canada, China, Denmark, Finland, France, Germany, Japan, the Netherlands, Norway, Singapore, Slovenia, Sweden, and the U.S. The national differences, the countries for those are Canada, Denmark, Finland, Norway, Sweden, and the U.S. In the European Union, they have published 62368 in the official journal. This is just updated recently to include The references to the superseded standards here, you can see that 62368 is in fact going to supersede both 6950, the current edition, and 6065, the 2014 edition. And they've just also released a core addendum. It's a correction. It has about a half a dozen or so little changes or corrections that need to be made. On this slide, I wanted to point out two things, though. If you see this note 2.1 here and this big empty column to the right, those are very meaningful. The note 2 says that a new or amended standard has the same scope as the superseded standard. So 62368 has the same scopes as 6950 and 6065. And on the date stated, the superseded standard ceases to give presumption of conformity with the essential or other requirements of the union legislation. So again, I'll back up to this column that's empty. That's where the date would go. So to date, there are no dates of secession that have been published for the European Union. However, there have been dates of withdrawal stated, those for the superseded standards, 6065 and 6950. The date was June 20th of 2019. We expect that the date of withdrawal and the date of secession of presumption of conformity will coincide with that, be June 20th of 2019. And to date, no group differences have been published for the European Union. For the United States and Canada, the standard was issued jointly, UL 62368-1, and Canada CSA C22.2, number 62368-1-14. It was published in December 1st, 2014, and the date of withdrawal is also June 20th of 2019. And that's all I have. We'll now take a minute and try and answer some of your questions.
So that does conclude the presentation portion of the webinar. Tomorrow, an archived copy of this webinar will be available on metlabs.com. So we will send a follow-up email with a link to the file. Now we will answer questions. If you do have any questions, please type it in the questions area of your control panel. For questions we can easily address now, we will read the question aloud and then give an answer. So far we have no questions.
Okay, I've received a couple of questions, and for the most part, they're in a condition that I can't really definitively answer. The first one I will attempt to answer partially is, does 6950-1 go away completely for all products? I believe the intent is to withdraw the standard completely. However, my personal opinion is that it will likely linger, but I believe the stated intent is for 6950 and 6065 to be withdrawn completely for all products. Okay, I have a question. Are there any resources such as gap analysis between 6950 and 62368 to identify whether a product evaluated to 6950 will comply with 62368? There are none to my knowledge. There are some comparative documents out on the internet. We do have an option. A published TRF published by the IEC has a combination 6950 and 62368 TRF or test report form. It also includes 6065, so this question would also answer 6065. If you wanted to gain access to that document, you can see how they correlate and then compare the limits. I think in most cases that I can think of right now, the limits have been extended for 6950, so I don't think there would be a difficulty, but it is a different way of approaching, so we need to come at it differently. I'm asked my opinion on something. In my opinion, will the IEC issue an additional addition or amendments? Yes, I believe that they will. I think that there won't be another addition for a couple, 2 or 3 more years because of the preference to wait 4 to 5 years before we do it. But certainly there are already amendments. The core addendum in the European Union is one of them that's cropped up to show some differences, some corrections that need to be made. And as we move forward, we may have some of those pop up. Okay, I'm asked a question. Risk management be part of the evaluation, and if so, how? We addressed that early on in the presentation, but no, risk management really isn't part of the evaluation. It's not. That's a concept similar to 60601. We don't use risk management to that degree. We don't mitigate nonconformities by doing risk assessments, risk management assessment. Each and every hazard would need to be addressed and mitigated by the safeguards as identified in 62368. Okay. I'm asked, is there a CB scheme available for 62368, and if so, will it be accepted in all CB scheme countries? I can answer part of that, and that is yes, 62368 is a part of the CB scheme. It is in the scopes of several NCBs now, MED included. Any of our U.S. locations can conduct CB scheme evaluations to 62368. As far as whether it's accepted by all countries, that's dependent on the country, and you'd have to ask for specific countries, and then we would have to go out to the website to research that together. If you wanted to, you can find it at the IECE website, and I believe it's just iecee.org. If you'll just do a Google search, I think you can get there to answer the rest of that on which countries accept it. Okay. I'm asked if there are some safeguards that are not defined by the standard, but manufacturer should decide by himself about it. So who will decide if the manufacturer's safeguards are sufficient? And that's going to be a relationship thing between the certifying agency and the manufacturer. I anticipate a greater relationship necessary in order to complete a certification to 62368, where there is some passing back and forth of the equipment. But it is, while not prescriptively so, there are some things that need to happen, and you need to know that you're below these limits for the persons that are affected by the hazard. So we'd need to know the hazard and then make sure that it is mitigated in some way. And again, that's a relationship between the certifying agency and the manufacturer. And that's to be worked out. I would think in most all cases, the lab that is doing the certification would make the final determination as to whether or not it is acceptable or not issue a certificate. I'm asked the question, has Europe added the standards to the OJ under the low voltage directive? Yes, it's in there under the low voltage directive, and it is slated to replace 6950 and 60065. Okay, I'm asked how long NET will continue to test compliance to 6950. We will. It depends on what you mean by test compliance. For new products, when the data withdrawal has passed, we will probably no longer accept 6950. Up to that date, if there's a compelling reason to not use 62368, which of course will go on much longer than 950, if there's a compelling reason to stay with 950, then we can do evaluations to 950. For the United States, I believe we would still honor those certifications through the life of the product as long as there are significant modifications or changes to the product that might necessitate upgrading the standard. Okay, I'm asked a follow-up question. If one lab decides that a safeguard is okay, but another decides that it's not, what happens there? If there could be a conflict between the labs, and that's yes, I would have to assume that there could be a conflict between the labs. So the purpose of a CB scheme report, the idealistic purpose for it is to do one set of testing, one evaluation for all of these member countries. However, each country, each NCB has a right to question and ask for a sample if necessary for their own testing and evaluation. If one CB disagrees or one NCB disagrees with another NCB, then I guess we would have to develop relationships with that NCB and determine why. And if it's found that the originating NCB is in error, then that would need to be corrected. Else, that recognizing NCB would have to determine whether or not they would accept the product past that. Okay, the flow of the questions is stopped here. I want to pass it back to Sarah.
Okay, perfect. So if you do have any additional unanswered questions, feel free to contact us via phone or email. Tomorrow, like I said, we will send a follow-up email that will include a link to the presentation. That concludes our webinar. Thank you so much for joining us today.